Okay, so now we have to go backwards. What is the order for us to go ahead and take something that is expanded and bring it back to a single logarithm? Well, we're going to go backwards. In example 6, notice we did quotient rule first, then product rule, then power rule. So we are literally going to go backwards to do this. We're actually going to first apply the power rule, the power property, then the product rule, and finally the quotient rule. So we literally are going to go backwards. Let's go ahead and see an example. It says use the product and quotient rules to combine logarithms. So we need to rewrite log base 3 of 5 plus the log base 3 of 8 minus the log base 3 of 2 as a single logarithm. No problem. When you have expanded through addition, it means that they were put together with multiplication. So I'm going to rewrite that as the log base 3 of 5 times 8. The subtraction, if you remember, came from the quotient rule, which means that I'm dividing by 2. So I multiply and divide. So this is equal to the log base 3 of 40 divided by 2, which is simply the log base 3 of 20. Okay, so now we're ready to try a more challenging problem. So in this particular case, our job is to condense, not expand, to condense as a single logarithm. Okay, no problem. So the first thing we need to do is apply the power rule. We have to look to see if we have any powers. Right here, I have a 1/2 in front of log. That is going to be the power. I have a 3 in front, and that is going to be the power. So the first thing I'm going to do is take care of the power rule. So I'm going to rewrite this as the log base 2 of x squared, which already has a power in it, so I didn't have to do anything there, plus the log base 2 of x minus 1 to the 1/2 power, which remember is just the square root, minus the log base 2 of x plus 3 squared to the 3rd power. So we are going to have to do some simplifying. This is the log base 2 of x squared plus the log base 2 of the square root of x minus 1 minus the log base 2. Remember, by the rules of exponents, a power to a power, you multiply the powers. So that is the log base 2 of x plus 3 to the 6th power. So once I went ahead, that is just applying the power rule. Now we're going to go ahead and apply the product rule. We have to see if there's anything that's added together that means that it was multiplied. So at the very beginning, I have the log base 2 of x squared times the square root of x minus 1 minus the log base 2 of x plus 3 to the 6th power. So I went ahead and I applied the product rule. My last thing to do is to apply the quotient rule. So the quotient rule is when I see subtraction, which I do right here. And so finally, it's going to leave me with a single log base 2, a single logarithm, and I'm going to have x squared square root of x minus 1 all over x plus 3 to the 6th power, and that is going to be my final answer. Let's go ahead and move on to example 11. Go ahead and pause the video to see how well you can do this on your own and then press play. As a reminder, we are going to go first power rule. So I'm going to go ahead and be on the lookout for any numbers in the front because they are the exponents. So here, the 4 is going to go with x plus 5. The 1 over x is going to be the power for the 3x plus 5. So I'm going to go ahead and take the time to rewrite this as the log of x squared minus the log of x plus 5 to the 4th power plus the log of 3x plus 5 to the 1 over x power. And the 1 over x power is interesting Remember that 1 over x really means x to the negative 1. So one of the things that I can do is that I can go ahead and just rewrite that so that I see it as x to the negative 1. Sometimes it's personal choice. It's not really something you have to do, but you might see it written that way and then you can recognize it. Okay, so one of the things that's interesting right now is that we are possibly better off rewriting this. So that way, if you notice, this is positive. This is a plus log 3x plus 5 to the 1x power. And this one right here is also positive. So those two, I can rewrite them together because they're both positive. And the only thing that's minus is this part right here. That is going to go in the denominator through the quotient rule. If this log 3x plus 5 to the 1x power was meant to be in the denominator, I wouldn't see a plus, I would see a minus, because it meant that that minus would have been distributed and then that part would have gone in the denominator as well. But because I don't have that situation and what I have instead is that plus, then I am going to take the time to rewrite the problem as the log x squared plus the log 3x plus 5 to the 1x power minus the log x plus 5 to the 4th. And this is going to make it easier for you to realize, okay, I know that I have to multiply these two at the beginning, and the only part that's going to go in the denominator is going to be x plus 5 to the 4th power. So again, minus the log of x plus 5 to the 4th. And then now I can just put it all together finally, where I'm now ready to put this in my denominator because I'm dividing. So now this means that I can finally get my final answer, which is the log of x squared 3x plus 5 to the x to the negative 1. I'm using this property right here to rewrite that. All over, because I'm dividing by x plus 5 to the 4th. And this is how you can rewrite this as a single logarithm. Last but not least, we have what's called the change of base formula. The change of base formula is helpful because what it's going to do is allow me to rewrite this with the same base. Notice the change of base formula. I can rewrite the log base b of m as the log base n of m divided by the log base n of b. I always tell my students to think of it in terms of the big number over the little number, okay? So it's the log base n of m over the log base n of b. And it's called the change of base formula because both of these now are going to have exactly the same base. And sometimes it allows us to simplify this. As a reminder, when you see log by itself and no number next to it, it's the common log. So the example they're giving us is the log base 5 of 36. Remember what this really means. So this is you thinking about this. What this really means is that 5 to some power equals 36. And you're like, well, 5 squared is 25. 5 cubed is already 125. So it has to be 2 point something, probably closer to 2 than it is to 3, because 5 squared is 25 and 5 to the 3rd power is 125. So instead, one of the things that we can do is use a change of base formula, and I can say, let me take the log of 36 and divide this by the log of 5. When I have a log with log with no base, it's base 10, and the calculator can do it for you. So if you divide this, it's going to be approximately 2.2266, which again makes sense because I told you the answer should be closer to 2 than it is to 3. So that's basically it. That's the end of this lesson where we are learning about the change of base formula. And again, you can use either log or you can use natural log. When you see log by itself, it is the common log base 10. And when you see ln, of course, it's based on the natural base, which is base e. Hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.